I just finished giving a talk at the Nanospace conference in Kaunas, where I discussed the capabilities that the Felix laboratory can offer in the context of astrochemistry and carbon-bearing molecules in space. So in this talk, I presented what Felix can offer. So this is a research institute in Nijmegen in the Netherlands, where we have a set of free electron lasers that are designed to provide tunable and intense light in the far and mid-infrared range. And therefore it presents these unique opportunities to do spectroscopy in various experimental conditions right in the spectral range where JWST is sensitive. And so at Felix we have different user stations, so different experimental setups where we can do a spectroscopy on ions in cold conditions and also at room temperature. And in particular in my user station, in my setup, we do a spectroscopy of carbon-bearing molecules in the infrared range, in particular in molecular beams, and then focused on neutrals. Because in space we know that several molecules have been identified, but while many of them are ions, most of them are neutrals. So at the moment that JWST is providing this high sensitive data in the infrared, we need to also have a spectroscopic data in this wavelength range, but also on sort of astrochemically relevant conditions. So this is low temperatures and low densities. And so molecular beam experiments are ideal so that we can then compare our experimental data with the observations of JWST. So in my talk I introduce the capabilities of my user station by discussing the way it works, how do we form these molecular beams, and in particular I went through some examples of the type of research we have been doing in the last couple of years in the context of carbon-bearing molecules in space. So I presented in particular 4 examples. First I discussed the experiments we can do on pHs, polycyclic aromatic hydrocarbons, so different kind of pHs, so these can be pure pHs, substituted pHs, and how can we do a spectroscopy on them and the efforts we do to then contrast our experiments with astronomical observations. Then I also discussed that we can also form clusters of species made out of carbon. So in particular I discussed recent work on carbon clusters. So we can produce a distribution in the molecular beam of small carbon clusters and how we can do a spectroscopy on them. And in particular, even though in the molecular beam we have a distribution of these carbon clusters, we can selectively get their infrared spectra. So we can know the spectra of carbon-6, carbon-7, carbon-8 independently. Then I discussed that we can also form in these cold conditions of the molecular beams weakly bound complexes with carbon-bearing molecules. So in particular, we can form these complexes between pHs and molecules such as water, CO, CO2, which is kind of like an intermediate, like the first steps of the formation of interstellar ice. And so I presented the spectroscopy we have done on naphthalene interacting with water, and the fact that even at this cold temperature of the molecular beams, water is mobile at the surface of the naphthalene, and that has some very specific signatures in the IR spectra. So I show how we can identify from an IR spectra the fact that these weakly bound complexes are not static, but they are dynamic at the cold temperatures of the molecular beam. And finally, I discussed that we can also form large clusters of pHs, which have been proposed to be present in cold conditions in space. So we can form large clusters of pHs, and we can also do a spectroscopy on them in a size specific way. So we can also have tools where we can get the spectra of just phenanthrene 5, phenanthrene 6, and so on. So this provides an ideal tool to then try to identify these molecules in space. So that was my talk about So this sort of general summary of the things we can do at my station and what Felix can do